Hello everyone, just wanted to go through what I hope is going to be a quick video from lesson 2-4. We need to talk about slopes of parallel and perpendicular lines. Before we get into this, let's review a little bit. How much of this did you actually retain from your algebra class? When I say slope of a line, I know some of you are going to blurt out y equals mx plus. No, hold on. Before we get there, the slope formula itself, y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. That's the slope formula. If you know the coordinates of 2 points on a line, we should be able to calculate the slope of that line. Now, of course, you know y equals mx plus b. What about the third one down here? The point slope form of a line. For example, if somehow you were given a line goes to the point 2, 7, and it has a slope of 3/2. Write the equation for that line. Well, okay, m is slope, we know that one. But the point 2, 7 is definitely not the y-intercept. So we can't simply substitute one of those numbers there. Since you were given a point and the slope, using the point slope formula seems like that would be appropriate. Now again, the x and the y without the subscripts, those are the variables in the equation. You need to leave those. X sub 1, y sub 1, and m, those are constants. We should substitute. So we're going to write y minus 7 is equal to 3/2 times the quantity x minus 2. So the y sub 1 is the y coordinate of the given point, the x sub 1 is the x coordinate of the given point, and m is, of course, slope. Then you would simplify, you would get rid of the parentheses. You would combine like terms, and we would get y is equal to 3/2 x plus 4, and that is your much more familiar slope-intercept form. Okay. You might be given things in standard form. I don't anticipate a whole lot of that here in this particular section. They just wanted to draw a fancy picture here showing a hill and a gondola line 2 feet above the ground go up the hill with the same slope, meaning that they're parallel. And again, this one here, not too tough. Two non-vertical lines are parallel if and only if their slopes are equal. Yay, biconditional statements. You might be a little bit, what is going on here? Why do they have to have that introductory two non-vertical lines? Hopefully you remember from our slope formula here, if we have a line that goes through the point 3.7 and a line that goes through the point 8.7. Can you picture what kind of a line that is? That was a yes or no question. So we'll take the difference in the y's divided by the difference in the x's. 0 divided by 5 is 0. This is a horizontal line. It doesn't have positive slope going uphill, doesn't have negative slope going downhill. The slope is 0, it's horizontal. versus something like 3, 7, 3, 10. 10 minus 7, that's a 7, I swear it is. 3 divided by 0. Matt, what is going on there? Can't do that. This is undefined, which is our indication that this is a vertical line. Now, you may have also heard it described as vertical lines have no slope. Be careful, though. That's not the same thing as saying that the slope is 0. 0 is a real number. You can do the calculations, and the slope, it can be exactly equal to 0. That's perfectly fine, perfectly acceptable, and perfectly horizontal. If we have an undefined slope, that means it's a vertical line. And that's why they put the phrasing in here. And as a matter of fact, go through the effort of adding a second sentence, any two vertical lines are parallel. So they'll throw stuff at you like this, where here's a nice graph. Is line parallel to line N? Please, there is no such thing as the looks like it. Yes, they are parallel. Why? It looks like it. Do the calculations. Find coordinates. Back up your answer with real, genuine reasons. So if we look at line K, the slope there will reduce down to -4/5. We look at line N, pick a couple of points there. That's -4/3. Oh, so close. But no, that really doesn't count. Two lines are parallel if their slopes are exactly equal. Okay. Two non-vertical lines are perpendicular. Oh, I hate the way this theorem is always phrased. If the product of their slopes is -1. So if you're going through and you find that the slope of one line is 4/3, the product of their slopes is equal to -1. That really doesn't help you all that much. For the perpendicular to 4/3 should be -3/4. I prefer the description here where it's the negative reciprocal. So if my first line is +4/3, the slope of any line perpendicular to that will be -3/4. If the line has a slope of -1/8, the slope of anything perpendicular to that is going to be +8/1. In other words, just 8. Okay, hopefully we remember how to deal with nice integers. So what they have in the theorem here, I would prefer we refer to this as the perpendicular lines and slopes theorem. It's absolutely true, but it's really not all that helpful. And again, a big jumble of stuff here. Check to see if line J is perpendicular to line K. So again, hopefully we should be able to tell from the graph, line J goes to the point -1, 5 and the point 1, 2. I like how they color code these things because it is so easy to make the mistake of matching up a X and a Y coordinate when no, you're supposed to match up X with X and Y with Y. And then line K goes through -3, 2, and hey, look at that, the y-intercept at a rather convenient 0, 4. So that has a slope of 2/3. Now compare -3/2 and +2/3. Yes, they are negative reciprocals. They have to be different in two very specific ways. One should be positive, one should be negative, and then they should be flipped. They should be reciprocals of one another. And then you got to write, what is an equation of the line that goes through point P that is parallel to line L? Well, in this case, that's not too bad. The fact that they gave you the equation for line L in slope-intercept form, and there was much rejoicing. Y is equal to 1/2 x minus 3. The slope of line L is 1/2. So if we want the equation of a line parallel to it, the slope of our second line is also going to be 1/2. And now that we know the slope and we know the coordinates of a point, this is why I wanted to refresh your memory there on the point slope form of a line. Or you can do the cheater's way of doing that. I'm sorry, I'm being a bit facetious here. Yes, you could use y equals mx plus b. Substitute 4 in place of x, 1 in place of y, and 1/2 in place of m, and then we can solve it for b. Once we have the value for b, then we can use that to write the equation. My preference is I use the point slope form of a line and I simplify it. I have the equation. I don't have to solve an equation and then use another equation to write the equation. I have it. My simplified answer is the equation. So that's pretty much it. Okay, so don't get too frustrated. Take your time there with writing equations of lines. Oh, did they? Oh, yeah. What's the equation of a line that goes through point P that is perpendicular to line L? So again, you know the perpendicular line is going to have a slope that's the negative reciprocal of positive 1/2, should be -2. And again, if it's going to be perpendicular, I wish they would have drawn the graph here. Notice there that y-intercept is all the way up at +9. Okay, again, if you're thinking about the perpendicular there, they should have very, very different y-intercepts. And that's pretty much it. Okay, so you get some practice here going back to algebra and refreshing your memory about equations of lines. Don't rip through it too fast because that's where the silly arithmetic mistakes get made. Okay, be precise, be accurate. Take a look at the Realize website for the assignment from this. Next time we'll talk this over, any questions that you have either from 3 or 4, and we'll probably do another quiz. Okay, so a quiz over sections 3 and 4, and then we'll move on from there.